Imagine standing at the edge of a smoldering volcanic crater. Beneath your feet, the earth trembles gently alive, restless, powerful. It's always on. It doesn't rely on sunlight or wind or waves. But only in the last century have we begun to understand how to harness this energy at scale. Today, we are on the brink of a new era, one where volcanoes may do more than shape landscapes. They may shape the future of civilization itself. Imagine volcanic regions like the Ring of Fire, which encircles the Pacific Ocean, stretching from the Andes to Japan, from Alaska to New Zealand. This is where things get intense. At extreme depths and pressures, water becomes something entirely different, a supercritical fluid that behaves like both a gas and a liquid. And yet, engineers are trying. In Iceland SIDDP project, the Iceland Deep Drilling Project, they drilled into a volcano and struck a reservoir of supercritical water. The result was an energy monster. A single well could theoretically power 50,000 homes. It's far more efficient at transferring heat and regular steam. If we can drill deep enough, we could unleash 5 to 10 times more energy than conventional geothermal sources. It requires exotic metals, advanced cooling systems, and technologies that are still being refined. The hydrogen becomes clean fuel used for cars, planes, or even backup electricity. In water-scarce regions near volcanic zones, geothermal power could be used to remove salt from seawater, turning oceans into drinking water. This could transform arid islands and coastal nations, allowing them to grow food and support life where once it was impossible. What happens if tapping too much heat alters natural systems? Could we accidentally trigger eruptions? Could political instability or poor regulations turn geothermal zones into contested resources, just like oil fields today? And because geothermal is continuous, it could provide the steady power needed to produce hydrogen efficiently year-round. Not only would we get energy, we might also reduce the risk of eruptions. It sounds like science fiction, but studies are exploring how controlled heat extraction could stabilize pressure under a volcano. Indonesia, Kenya, the Philippines, Japan, and even parts of the US like California and Hawaii sit on volcanic gold mines. It's whether we should. Will we respect their power or try to dominate it? Will we extract energy carefully or recklessly? Will volcanoes be our partners or our warnings? With the right investment, technology, and safeguards, volcanoes could provide clean energy to billions. On the Moon and Mars, where solar energy is limited and batteries don't last forever, geothermal-style systems could keep habitats warm and powered. NASA is already exploring how volcanic-like lava tubes could shelter astronauts and maybe even provide power. Second, the risk. What happens if you trigger seismic activity? What if you disturb a magma chamber? The stakes are high. Mistakes could be catastrophic. These areas are not just danger zones, they're opportunity zones. Geothermal plants could tap into subterranean reservoirs of superheated water, turning it into steam to spin turbines and generate electricity. What if we built next-generation geothermal plants around the world's volcanoes? The same fire that once destroyed Pompeii may one day power entire cities. We could provide baseload energy clean, constant electricity without the carbon emissions of coal or gas. Unlike solar or wind, geothermal doesn't need batteries to store power. It's always flowing. In 2024, researchers at Stanford proposed a bold new concept, using molten magma as part of a long-term energy storage system. It works like this. Excess electricity from solar or wind farms is used to pump water into volcanic rock, where it becomes steam. When needed, the steam is released to power turbines. It's like tapping into Earth's natural battery. It doesn't pause at night or falter during cloudy weather. It's one of the most volcanically active places on Earth. And yet, Iceland has done something remarkable. Nearly 90% of its homes are heated using geothermal energy, and around 25% of its electricity is generated this way. Volcanoes don't just loom in the background there. They keep the lights on. This energy, flowing ceaselessly from the bowels of the earth, represents one of the cleanest, most consistent sources of power available to us. From the depths of the planet's core, unimaginable heat and pressure are released in a spectacle of molten rock and fire. For centuries, we have feared volcanoes. We have studied them, fled from them, and built myths around them. But now, humanity is starting to ask a radically different question. Can these monstrous giants be tamed not as threats, but as allies? Could volcanoes power tomorrow's world? At the heart of a volcano lies a force that never sleeps: geothermal energy, an immense reservoir of heat generated by the radioactive decay of elements in the Earth's mantle. And it is ancient. Indigenous peoples from Iceland to Indonesia have long bathed in hot springs and cooked meals using volcanic steam. Let's look at Iceland. This small island nation sits directly atop the mid-Atlantic Ridge-Seam, where tectonic plates tear apart, letting magma rise close to the surface. But Iceland is only the beginning. And here's the exciting part. Volcanoes offer not just shallow geothermal sources, but access to what scientists call supercritical fluids. But drilling that deep isn't easy. Temperatures exceed 400 degrees Celsius. Materials degrade. Equipment fails. The rock becomes more like taffy than stone. Now picture this on a global scale. But there are challenges. First, the cost. Drilling into a volcano isn't cheap. But some scientists believe we can go even further. What if we could cool down volcanoes intentionally by drawing out their heat? And then there's the craziest idea of all volcano batteries. Volcanoes might also power green hydrogen production. With enough geothermal heat, we could split water into hydrogen and oxygen. Let's also talk about desalination. Volcanoes even have a place in space exploration. The future is not without risks. Some worry about unintended consequences. And yet, the opportunity is vast. Over 40 countries already have significant geothermal potential. Ultimately, the question is not whether we can harness volcanoes. As we race toward a future desperate for clean energy, the ground beneath us may hold the answers. And maybe, just maybe, that's the destiny volcanoes were always meant for.